Imagine you spend a Friday afternoon, right, building this shiny new AI feature for your company.
Oh, the classic Friday afternoon deployment. Always a good idea.
Right. Yeah, exactly. And it feels magical. You wire up a language model to your internal databases, you ask it a question, and it gives you a perfect answer.
Best feeling in the world.
It is. So you deploy it to production, you pack up your things, and you go home for the weekend.
Mm.
But then Monday morning, you walk into an absolute nightmare.
Uh-oh.
Yeah. Over the weekend, your AI encountered a user query it didn't quite understand. So it hallucinated a command, got an error back from your database, tried to fix its own mistake, got another error, and basically spent the next 48 hours trapped in a manic, invisible loop,
Wow.
just silently burning through like $5,000 of OpenAI API credits while generating absolutely nothing of value.
Yeah, that is a terrifying scenario. And honestly, it's happening to development teams all over the world right now.
Really, just burning cash like that.
Oh, yeah.
Yeah.
Because when you move past a simple, ask a question, get an answer interface, the fundamental physics of your software completely change.
How so?
Well, you are suddenly giving software the autonomy to think, to use tools, and to iterate. It stops being a predictable script and starts acting like a highly enthusiastic, yet occasionally unhinged intern.
Unhinged intern. That's a great way to put it.
And, managing that intern is an entirely new discipline.
Which is exactly why we are looking at this specific stack of sources today. We've gathered a ton of technical documentation, architectural comparisons, and up-to-date pricing guides surrounding the LangChain ecosystem.
Yeah, there's a lot to dig through here.
There really is. We are going to decode the differences between LangChain, LangGraph, LangSmith, and LangFlow. The mission for this deep dive is to give you, the listener, a clear, actionable map of what these tools actually do under the hood.
Right, and what they cost, which is huge.
Exactly. What they cost and when you should use which. Think of this as a shortcut to becoming an informed AI builder, allowing you to skip the painful, really expensive trial and error of production-grade development. Okay, let's unpack this.
Let's do it because, the stakes are incredibly high for anyone building software today. Moving from those simple conversational chatbots to reliable, multi-step autonomous agents, it requires a complete architectural rethink.
You can't just slap a prompt in there and call it a day anymore.
Exactly. You need orchestration to control what the AI does, robust observability to see how and why it's failing, and strict flow control to keep it from spiraling. Building an AI app is no longer just about writing a clever paragraph of instructions for a language model.
Right. So before we get into the truly wild stuff, the complex autonomous agents making independent decisions, we really need to understand the basic materials.
The building blocks.
Yeah, we need to look at the engine and the blueprint. So let's start at the foundation with LangChain and LangFlow.
Right. So LangChain is really the bedrock of this entire ecosystem. It's a code-first, general-purpose toolkit for building applications powered by large language models.
So this is the raw code.
Exactly. If you are building a relatively straightforward tool, say a basic retrieval augmented generation pipeline.
Right, you.
Yeah, RBRUN, which is just a fancy way of saying the AI reads a specific set of your documents, like an employee handbook or a legal contract, and then answers user questions based strictly on that text.
Okay, got it.
For that kind of straightforward task, LangChain provides a massive library of pre-built integrations. I mean, it connects to almost any database, any vector store, and any language model you want to use. And it is open source and completely free to use.
Free is always good. But reading through the documentation, though, is pretty clear that LangChain forces you into a specific way of structuring information. It heavily relies on a linear or DAG-style flow.
Right, the directed acyclic graph.
Yeah, DGG, which sounds incredibly dense, but it basically just means the information only ever moves forward. It's like a water slide.
Oh, I like that. A water slide.
Right. You drop the prompt in at the top, it slides down through a few predefined processing steps and splashes into the pool at the bottom. You call it once, and you get a result.
The water slide is actually a highly accurate way to look at it, because there is no swimming back up the slide.
No, that would be a disaster.
Right. In LangChain, the state, which is the memory or the context of what the application is currently doing, is largely implicit. The framework doesn't automatically remember what happened on step 1 by the time it gets to step 5.
Oh, really?
Yeah, if you want it to remember, you, the developer, have to manually manage the persistence of that memory in your code. Furthermore, because LangChain tries to be the universal adapter for every AI tool on the market, its API surface is massive.
Let's try and do everything for everyone.
Exactly. Developers often complain of a steep learning curve simply because there are so many different classes and functions to navigate.
Which seems to be the exact problem that LangFlow was built to solve. If LangChain is the raw Python code, LangFlow is the visual interface.
Yes, the UI layer.
It's an open source, low-code builder. You just open a web browser, and you get a drag-and-drop user interface where you can visually wire together different language models, APIs, and document retrievers. So is LangChain basically a giant, complex box of loose Lego bricks? Well, LangFlow is the visual instruction manual that lets you snap them together without needing to know how the plastic is actually manufactured.
That captures the dynamic perfectly. LangFlow is essentially, well, no-code LangChain. When you draw those nodes and connect them with edges on your screen, LangFlow is quietly generating all that complex LangChain Python code in the background.
That sounds incredibly convenient.
It is. It is a phenomenal tool for non-developers, product managers, or engineering teams that just need to throw together a rapid proof of concept for a stakeholder meeting. You can build a functioning prototype visually and even export it directly as an HTTP API to integrate right into your website.
But I imagine a visual builder hits a wall pretty fast, though. I mean, you can only draw so many spaghetti lines on a screen to handle different conditions before you physically can't manage the edge cases.
Oh, completely. It gets messy fast.
Right. At a certain point, to get the granular control you need for a secure, enterprise-ready application, you just have to abandon the visual canvas and drop back into raw Python code.
Yeah, the transition from prototype to production almost always requires that drop into raw code. LangFlow is fantastic for proving a concept works. But for true production-grade engineering, especially when you start introducing complex, nested logic or custom security protocols, visual builders begin to choke.
They just can't handle the weight.
Exactly. You use LangFlow to sketch the blueprint and get buy-in, but you need the raw materials of LangChain to actually pour the concrete and build a load-bearing structure.
Okay, so that transition from the simple straight-line water slide into something that can actually think and react brings us to a massive leap in complexity. Because what happens when your workflow needs to pause? Like, what if the AI searches a database, realizes the document is missing, and needs to formulate a brand new plan instead of just returning a dumb error? That's where we move from simple chains to complex graphs. Here's where it gets really interesting. We are stepping into LangGraph.
Yeah, LangGraph fundamentally changes the architecture. It is an orchestration layer built directly on top of LangChain, but it is specifically designed for stateful, multi-step, multi-agent workflows.
Now, I want to push back on this a little bit because I know what you might be thinking if you're a developer listening to this.
Okay, play devil's advocate.
If LangChain is already this incredibly flexible code-first framework, why couldn't I just write my own standard while loop in Python around my existing LangChain code? Like, if I want the AI to keep trying until it gets a good answer, I just write, well, the answer isn't good enough, keep asking the LLM. Why on earth do I need to learn a whole new specialized graph framework just to make my code loop?
It's a fair question, and developers attempt that ad hoc approach constantly, and it almost always ends in disaster.
Really?
Yeah.
Why is that?
Here is the mechanical problem with a standard Python while loop in this context. It has no inherent memory of its journey if something goes wrong. Let's say your custom Python loop is on step 4 of a 5-step reasoning process, right?
Okay.
The AI is trying to call an external weather API, but the API times out. Your Python script crashes. Because the memory lived only in that active loop, everything the AI learned and planned in steps 1, 2, and 3 is instantly vaporized.
It totally amnesias. You just lose it all.
It's gone.
So you have to start all over again from step 1, which means you're paying for all those LLM API calls a second time.
You pay twice and you add massive latency for the user. What LangGraph does differently is introduce a strictly defined explicit state object.
Explicit state, okay.
You can think of it as an immutable ledger or a persistent event stream. Instead of just overwriting variables in memory, LangGraph constantly saves the entire context, every thought, every tool call, every piece of data to a database checkpoint after every single node in the graph executes.
So if it crashes on step 4 because of a network timeout,
The system doesn't panic. LangGraph has built-in fault tolerance. Because the state was safely checkpointed to a database at the very end of step 3, the system simply pauses, waits for the network error to resolve, and resumes the graph from the exact millisecond it left off.
Using the exact same context.
Exactly. That architectural reliability is absolutely vital if you are running multi-agent systems that might take minutes or even hours to complete a task.
And because it is structured as a directed graph rather than a straight line, it allows for true cyclical logic. An AI agent can create a plan, act on the first step, evaluate the result, realize the result was poor, revise its own plan, and loop back to try a different tool.
Yes.
It can loop as many times as it needs to.
What's fascinating here is how this architecture actually mimics human organizational structures. It enables true multi-agent collaboration. You can build one node in your graph and designate it as the researcher agent, giving it access to web search tools.
Okay, so it just Google stuff.
Basically, yeah. Its only job is to gather data and update that shared state ledger. Then, the graph passes control to a writer agent node. The writer looks at the ledger. If the writer determines the research is too shallow to draft a good report, LangGraph's conditional edges allow the writer to reject the data and loop the flow backward,
Forcing the researcher to go dig deeper.
Precisely. It is a fully modeled asynchronous workflow, not just a brittle script.
Which brings us to perhaps the most critical feature mentioned in all of these sources regarding LangGraph: human in the loop, or HITL.
Oh, this is massive.
Right. Because this state ledger is explicit and constantly saved to a database, you can literally design a node in your graph that just says stop computing and wait for a human.
For any enterprise application handling sensitive data, human in the loop is a non-negotiable requirement. I mean, imagine an AI agent tasked with reading customer emails, determining if they deserve a refund, and drafting the wire transfer request.
That sounds like a recipe for going bankrupt.
Right. You absolutely cannot have a language model firing off wire transfers automatically. With LangGraph, you route the flow to an explicit pause point. The graph halts. The state is saved.
And then a person steps in.
Yes. A human manager logs into a dashboard, reviews the AI's reasoning on the ledger, verifies the customer's history, and clicks an approve button. Only then does the graph resume and execute the transfer. It transforms an unpredictable AI from a loose cannon into a highly supervised, extremely capable digital employee.
Okay, so we have covered the visual blueprints of LangFlow, the foundation of LangChain, and the looping, stateful neural pathways of LangGraph. But this brings us back to the nightmare scenario we opened the show with.
The Friday deployment.
Yeah, the Friday disaster. When you have these multi-agent graphs endlessly looping, delegating tasks, and revising their own plans behind the scenes, how do you actually see what they are doing?
The real problem.
Right. If the system breaks, how do you look inside the black box? And more importantly, how do you make sure that infinite loop isn't destroying your budget?
The solution to that visibility problem is the third major pillar of this ecosystem, and that's LangSmith. If we want an accurate metaphor, LangSmith is the flight data recorder for your AI applications.
The black box recorder.
Exactly. It captures every single granular detail leading up to a crash.
Now, the forces describe it as an observability and testing platform, but they also use a lot of DevOps jargon, calling it an APM for large language models. For anyone who doesn't live in server infrastructure, what does that actually mean?
So APM stands for Application Performance Monitoring. Think of it as a highly sophisticated heart monitor for your software. In traditional software, if a user clicks a button and gets an error, an APM dashboard tells the engineers exactly which database server failed and how many milliseconds it took to fail.
Okay, that makes sense.
But traditional APMs are basically useless for AI, because when you query an LLM, it isn't fetching a static row from a database, it is generating text probabilistically.
Right, so the model might give you a brilliant answer on Tuesday and completely hallucinate on Wednesday, using the exact same prompt.
Which makes debugging a complete nightmare. LangSmith solves this by logging full, deeply nested traces of every single execution. It acts like that flight data recorder, allowing you to rewind the tape.
Oh, wow.
Yeah, it records the exact prompt your application sent to the model, the exact text the model generated in response, the specific tools the AI decided to use, the exact number of tokens consumed, and the latency of every single step.
So it's a complete paper trail.
A complete paper trail. So if your multi-agent customer support bot suddenly tells a user something wildly inappropriate, you open LangSmith. You look at the visual call stack and trace it back. You might find that on step 2, the retriever pulled an outdated company policy, which poisoned the context window, causing the writer agent on step 5 to hallucinate.
That level of forensic detail is incredible. But the sources also emphasize that LangSmith treats testing as a first-class citizen. which seems equally important.
Oh, definitely. Testing AI requires a totally different paradigm. In normal software development, you write unit tests, like if I input 2 plus 2, assert the output is 4.
Simple math.
Right, but you can't do that with language models because the phrasing of the answer changes every time. Instead, you need evaluation datasets, or evals. LangSmith allows you to curate a dataset of, say, 1,000 historical user questions and the ideal baseline answers.
So you test against history.
Yeah. If you want to see if switching from OpenAI's GPT-4 to Anthropic's Claude will save you money without hurting quality, you run your LangGraph application against that 1,000-question dataset inside LangSmith. It uses automated evaluators to track regressions.
So it tells you if it got worse.
Exactly. Did the accuracy drop? Did the latency spike? Did the overall cost decrease? It gives you empirical data instead of just guessing.
Speaking of cost spiking, I have to ask a pointed question here on behalf of anyone actually trying to build a profitable business on this technology. The pricing documents make it clear that LangChain and LangGraph are open source. You can run them on your own servers for free.
Free as in beer, yeah.
Yeah, right. But LangSmith is a paid SaaS product software as a service. The pricing model is $39 per user per month, plus usage-based fees for every single trace logged beyond the free tier. So if I launch an app and it scales to millions of runs a month, won't paying LangSmith to record every single probabilistic thought my AI has completely bankrupt me? How do companies actually afford this level of observability at scale?
It's a great question, and the pricing documents highlight this as the ultimate reality check for scaling AI. At high production volumes, say, over 1 million runs a month, LangSmith traces can quickly become the largest fixed-cost add-on in your entire infrastructure, second only to the LLM API calls themselves.
It's rough.
It is. If you are paying between 50 cents and $2.50 per 1,000 traces, and you have a multi-step agent that executes 10 million individual nodes a month, that sauce bill is going to be astronomical.
So what is the practical solution? Because you obviously can't just turn off the flight data recorder once you're in production. If you fly blind, you won't know why the AI is hallucinating or insulting your customers.
No, you never fly blind, but you don't need to record every single peaceful flight either. The architectural guides outline 2 strict strategies for this: sampling and tiering.
Okay, how does sampling work?
With sampling, you configure LangSmith to only record 10% to 30% of your production traffic. Statistically, that is more than enough data to spot latency trends or recurring hallucinations without paying for 100% trace coverage.
That makes a lot of sense. And tiering.
Tiering applies risk-based logic. You turn off full tracing for simple, low-risk interactions, like a user asking the chatbot for your company's mailing address.
Because who cares if it takes an extra millisecond?
Exactly. But you keep 100% tracing enabled for high-risk flows. For instance, if the agent is handling billing adjustments or complex content moderation, you only pay to run the diagnostic scan when the system is doing something dangerous.
Okay, so what does this all mean? Let's bring this down to earth and look at how to actually architect this stack and when you should potentially abandon this specific ecosystem entirely.
Let's do it.
Because synthesizing all of this, it sounds like you only buy into the full LangChain, LangGraph, and LangSmith stack if you are building an enterprise-grade, highly complex agent. If you, the listener, just want to build a simple tool to chat with a PDF, adopting this entire alphabet soup of frameworks is massive overkill.
Oh, absolutely. If we connect this to the bigger picture, choosing your AI tooling is entirely about matching your architecture to the core value of your application. If you over-engineer a simple document reader with a stateful graph database, you will drown in maintenance and observability costs for no tangible benefit.
But the sources do outline a very specific recommended production path for teams that do need the complexity. It's a hybrid approach.
Yes, the hybrid is key.
You design your initial workflows and secure stakeholder buy-in using the visual drag-and-drop builder in LangFlow. Once approved, your engineers rebuild that logic using self-hosted LangChain and LangGraph to ensure you have complete control over the state and fault tolerance. Doing it that way keeps your orchestration licensing costs at exactly $0.
Which the finance team will love.
Right. And finally, you monitor that custom backend using heavily sampled LangSmith traces to keep the sauce bill in check.
That is the gold standard for deployment right now. However, we have to acknowledge the massive, unavoidable truth of AI economics.
Let's hear it.
No matter how perfectly you optimize your orchestration frameworks, your LLM API calls will still dominate your budget. You can host LangGraph for free, but if your graph is poorly designed and loops endlessly querying a frontier model like GPT-4, your compute bill will completely destroy your profit margins.
Which perfectly illustrates why you need LangGraph to control the loops and LangSmith to monitor the token usage. It creates a self-regulating ecosystem.
Exactly.
But the technical comparisons in our sources are very impartial.
Yeah.
We shouldn't pretend the LangChain ecosystem is the only game in town. What if my application's primary value is just pure document search?
If you are building robust knowledge bases, you should look heavily at frameworks like LlamaIndex or Haystack. They are specifically optimized for the nuances of indexing, chunking, and retrieving data, rather than focusing on complex tool-using agents.
And what if I do want those multi-agent workflows, but I really don't want to get into the weeds of explicitly defining graph nodes, edges, and state ledgers? What if I just want to write a prompt that says, you are the manager, you are the writer, go figure out this task together?
For that conversational approach to orchestration, you should explore tools like CrewAI or Microsoft's AutoGen. They use role-based multi-agent coordination. Instead of drawing explicit state machines, you give the agents personas and system prompts, and you let them converse and delegate naturally to solve the problem.
That sounds a lot more intuitive for non-engineers. And finally, the build versus buy dilemma regarding observability. Let's say I'm building a massive application, I need deep tracing, but I absolutely refuse to be locked into LangSmith's trace pricing.
Well, there is a thriving open-source observability ecosystem with tools like Langfuse or OpenElmetry. They offer incredible tracing and evaluation features without vendor lock-in.
But there's always a catch, right?
Yeah, always. It is crucial to understand the hidden costs of open source. Software might be free to download, but you have to provision the servers, manage the database scaling, and fix the tool when an update breaks your traces.
And engineer salaries aren't cheap.
Exactly. Often, the engineering hours you spend maintaining a free open-source tool end up costing significantly more than simply paying a $39 monthly SaaS fee. It is a classic trade-off. You either pay with your budget for a managed service, or you pay with your engineers' time to maintain it yourself.
It really is the age-old infrastructure debate, just updated for the era of generative AI. Well, we have covered an immense amount of ground today.
We really have.
We journeyed from the accessible visual blueprints of LangFlow down into the foundational code engine of LangChain. We explored the complex, stateful looping neural pathways enabled by LangGraph, and we learned how to monitor all of it using the flight data recorder of LangSmith without going bankrupt.
And when you architect these tools correctly, you elevate AI from a fragile parlor trick into a resilient, enterprise-grade software system capable of genuine autonomous work.
It truly changes what software is capable of doing. But I want to leave you with a final thought that builds on something we discussed earlier. We talked about how LangGraph enables brilliant human-in-the-loop designs.
Right.
You pause the complex AI graph so a human manager can review the ledger, approve the wire transfer, or correct the work before the AI continues. It sounds incredibly safe. It sounds responsible.
It's what everyone wants right now.
But as these orchestration frameworks get more sophisticated, as we use LangSmith to perfectly refine our prompts, and we rely on LangGraph to manage increasingly autonomous teams of AI agents that continuously plan, delegate, and revise tasks among themselves at lightning speed. At what point does the human-in-the-loop go from being the director of the workflow to simply becoming another node in the graph?
Wow.
Just another biological API endpoint sitting at a desk, waiting to be prompted by your AI manager for a quick approval click. Something to think about the next time your workflow asks you to verify a document.